class we played a game, and then you guys figured out that it was a pretty easy game, that it was very hard to win but very hard to lose, as long as you had two adults playing. And then someone said, oh, it's like tic-tac-toe, and that's exactly what it was. Okay, so the question is, how do you show that this game we played is isomorphic to tic-tac-toe? The way it's played, player 1 and player 2 each take turns selecting from the following, I'm calling them markers. Okay, there's 9 numbers that can be chosen. Player 1 and 2 choose the numbers until they are gone, one at a time. So for example, player 1 could pick 7, then player 2 can pick 6, player 1 can pick 3, player 2 can pick 5. Right? But the object of the game is to make sure that some collection of exactly 3 markers adds up to 15. So example, right now this player 1 wants to pick a 5, but they can't because player 2 just picked the 5. Alright, so too bad. So they pick something else and they're not very happy about that. Okay, and then player 2 wants to pick, wants to get a 4, and there's no 4, so they're not very happy. And so they have to pick something else. Okay, and you continue, and the deal is it's the same as tic-tac-toe, and this part you should remember, and if you can't, maybe you want to put this on your crib sheet. 5 goes in the middle, 2, 4, 6, 8 are the even numbers, and they make sort of a Z shape. Okay, and but I mean, you can make a Z shape like that, it doesn't matter, as long as it's a Z shape and they're not in a circle shape. And then you just find the 1, 3, 7, 9 that goes along with that. So let's see, 6 and 8 is the biggest side, the 1 goes there, so that adds up to 15. And this must be 3, and then this must be 7, and this must be 9, and we double check that we did this thing correctly. Yep, okay. This animal is called a magic square. Alright? And in a magic square, we have the situation where we have this row adds up to 15. In this case, all the same value, but 15. This adds up to 15. This adds up to 15. This adds up to 15, and so on and so forth. And these guys each add up to 15. Okay? That's what makes this whole thing work. The magic square implements our strategy for us. So, for example, if player 1 were to pick, when player 1 picks 7, you simply put an X over here. Player 2 picks 6, you put an O here. Player 1 picks a 3, you put an X here. Player 2 picks 5, you put an O here. Player 1 picks 4, you put an X here. And player 2 picks 2, and you put an O there, and so forth. So you can see there's one move for every move in our little game. There's exactly one corresponding move in Magic Square. And that's what isomorphic means. It means that these two games are intrinsically identical. Okay? And so you have to say something intelligent if this question is asked. All this discussion is great verbally, but you need to explain what you're saying. So you can, to show that it's isomorphic, you have to show that for every move in our game, let's call it our game, I called it something else in the answer key, there's exactly one possible move in our tic-tac-toe board, and vice versa. So the games are mathematically, and of course, and the winner doesn't change. It's not just that the moves are the same. I mean, obviously, it has to yield the same winners. I say, and yields same winner. Okay, so the games are mathematically identical. Okay, I said it differently in my other answer key, and I don't remember what I said. But what is important is that you're showing that there is a mapping. There is a correspondence that for every move in one game, there's exactly one possible move in the other game, and vice versa, and that they yield the same result when played out to their completion. And that's what makes them mathematically identical, in other words, isomorphic. Okay?